Hello everyone. So today I would like to start discussing about lines, angles, and polygons. Now you should already have some knowledge about what is a line, what is an angle, what is a polygon, but we'll be discussing most of those things from the very basic understanding. So don't worry if you don't remember most of those things right now. So first of all, a line is the shortest distance between 2 points. So let those be point A and B. So line AB here. So this is a segment of a line. It's a section, a cut, right? A piece of a line. This is a segment of a line, and it's well the shortest distance between point AB. So we can just say this is line. We could call line L, right? Or segment AB. Now, what I may do here is I may set some another line connecting A to point C. And if we observe AB and AC, they will have something between them. There is some measurement that we can take that tells us how is the slope of one compared to the slope of the other one, or how distant are they, but considering the slope, right? It's not a distance between 2 points, it's how different is their inclination. So we may call, for example, this angle A degrees. And that's one way to represent it, A degrees. If I took the measurement, let's say this is 45 degrees, I could simply say A degrees is 45 degrees. So this is one way for you to notate your angle. Also, you may use the points. So if we go through the line here, we would do BAC or CAB. The path here doesn't matter. Now, the point here is, since this is the point where your angle is, you have to add this. Now again, this is called a caret, the symbol here, right? So BAC is the same angle as CAB, which is the same angle as A. Now, when we're comparing angles, there are some special cases. So, for example, a complementary angle is, well, two complementary angles are the ones that add up to 90 degrees. So, if I make another line here, let's call this point here D now, I could say that DAC and CAB are complementary, because if you add them, you would have 90 degrees, which is a quarter of a turn. Now, two angles may also be supplementary, and that means that they add up to 180, which is half a turn, or a straight line. So let's take a look at a very quick example here. So we've got a few points here, A, B, C, D, E. Angle CBD is 30 degrees. Angle ABE is 90 degrees. If you have forgotten, this square here means 90 degrees, or a quarter of a turn. So, well, you can see obviously that ABC here is a straight line. So that's an angle of 180. So if ABC is 180, ABE here is 90. So if we were to write some of those things down, ABC here, what is that angle? 180 degrees. ABC, it's a straight line. Now what about ABE? Well, because this is a square, that means it's 90 degrees. So we also know that CBD, and again, CBD or DBC, so DBC or CDB makes no difference. It's the same angle. This is 30. So we know that this angle which is missing, let me call this A angle. So our A angle plus 30 plus 90 is 180 degrees, which is the full turn. Take a look again. I've added EBD here, which is our angle A, plus DBC, which is 30, plus ABE, which is 90, and that should be equal to ABC, which is 180. So that's what this expression means. Please, if you didn't follow this, go back a few seconds and take a look at this again. Now, what we can do here is, well, basically our algebra that we have been doing so far. We may subtract on both sides. So since we have 30 and 90 here together, they would add up to 120. So if we subtract 120 on both sides, we shouldn't change anything. And what we find is 180, well, this one will cross out. 180 minus 120 will be 60 degrees. So we have found our angle. Now, if I asked you, what is the relation? So, this answer here is 60 degrees. Now, if I asked you, what is the relation between angle A, B? No. Let's take this EBD and angle CBD. So I'm talking about CBD, this one, and EBD, this one here. So what do they add up to? So this one's 30, this one we have found to be 60. They add up to 90. So they are complementary angles. Now, take a look at this new problem here. If you're told that ABD and CBD are supplementary, what would be angle B? Well, what does it mean for an angle to be supplementary? Well, this means that ABD, which is this angle here, and CBD, just this one, they will have to add up to 180. Now, do I know any of those? Well, I know this one, and the other one is B. So basically this is our angle B, which we don't know, plus 45 should be 180. So here, just like we have been doing before, we may subtract 45 degrees on both sides. And if you do that, you will end up with those two will cancel out, and 180 minus 45 will be 135. So that's your angle. That's your answer. Now, I would just like to take this opportunity to introduce another concept, which is adjacent angles. And what are adjacent angles? So we mean that they share a vertex, which is those points here, right? Any of those points is a vertex. And they share an arm. So arm here is a line. Vertex is a point, and arm here means a line. So for example, angle ABD and angle CBD, they are adjacent. Why? Well, because they share a vertex, in this case B, and they share an arm, in this case BD. So since they share both a point and a line, they are what we call adjacent angles. So if you look at this new example here, A and B, they are not only complementary, right? So this means A plus B will add up to 90 degrees. That's what this means. But also, they are adjacent. And even though I haven't labeled those points here, for example, this could be called the origin, this could be point A, B, and C. So what is the vertex that they share? It's this point here, the origin. And what is the arm that they share? Well, OB here. So we have a common vertex and also a common arm. So that seems easy enough. Now let's take a look at what happens when lines intersect. Now, when we have two lines intersecting, so let me call this AB and CD, there will be some things here that will be quite useful for us to observe. Well, first of all, if we notice that this angle here, I'll call it angle A, will always be equal to this angle which is opposite to it. And we have some names for that. So if I call this B, they are the same value, and I could state that A and B are what we call vertically opposite angles. And even if I had angle C here and another angle D down below, C and D are also vertically opposite angles. But notice that those are in pairs. Alright, so C is vertically opposite to D and A is vertically opposite to B, but they are not vertically opposite. For example, A and C, they are not. Actually, what is the relation between A and C? So those two angles, they add up to a straight line. So the sum of them is 180. So they are, as we have just seen, supplementary angles. Same thing would happen for B and D. Now, if you find this a bit too far-fetched for you to accept, grab a scissor, preferably one without sharp edges, right? But if you open your scissor, so if you make that gesture to open it up and to put some paper between it to cut it, you will see that the angle that you're able to do here is exactly the same angle that you see up front. So those angles, they are always connected by this pivot point. This is the shared vertex here. And those are the lines which would be intersecting. Take a look. I could draw a line here and another line here. So they're intersecting. This angle here will be the same as this one. And this angle here will be the same as this one. And in this case, A plus B is always 180 degrees. Now, as you probably remember, or if you don't, this is a recap. Parallel lines, they will be expressed like this, with an arrow. So those two are some parallel lines. And there's one property that's going to help you a lot, which is if I have a line going through those parallel lines, there will be some angles which will be the same. Take a look. If I, let's say, if I investigate this angle here, I'll call it angle A. Do you notice that this is the same as this one? It's exactly the same angle. If I had another parallel line up here, then it would be the same angle again. So yeah, that's really useful when we have lots of lines. Also, there are other angles here which are the same. So obviously, for example, this one is the same as this one. And do we have any opposite angles here? Vertically opposite? Well, we do. This angle here should be the same as this one. And this should be the same as this one. And well, A also has some counterparts here. So A here is also the same because they are opposite. So vertically opposite angles are equal in size. And if you cut two parallel lines by a third line, the angles in corresponding positions, they will also be the same. So a very quick example here about this one. So very simple example here. What is angle B? You may pause and try it yourself. I will just go forward with it. Now, first of all, we can see that there are two parallel lines here. So as we have just discussed, when we have parallel lines being cut by a third line, the angles on similar positions will be the same. So for example, this is B here, so this will also be B. Or likewise, if this is 30, this is also 30. Now this line here is cutting our parallel lines, and well, this was a straight line, so there should be something that we know about beta and 30. So those two angles, they will have to be complementary. Oh, sorry, supplementary, right? 180. So they add up to 180 degrees. They are supplementary. So if there's, well, because it was a straight line, right? This here was a straight line before it was cut. So it was 180 degrees, and now it's cut into 30 and B. So B plus 30 degrees should be 180. Therefore, our angle B is 150 degrees, and that's our answer. So this here can also be summarized as when two parallel lines are cut by a third line, the co-interior angles are supplementary. Alright, so this is also 30, right? So the co-interior angles are supplementary. But you could also compare to this one, right? So basically those angles here, they will add up to 180, and you should always remember that the opposites will always be the same. So I'm showing you a few shapes here, some polygons, and let's discuss a bit about the angles. So when we have a triangle, the sum of the internal angles of the triangle is 180. Always. It doesn't matter which triangle you have. You may have a very skewed triangle, very like that, very stretched, I don't know. It's still 180. The shape does not matter. So those are the interior angles of a triangle. What about the exterior angle? So let's say here that, well, I know A and B, and I know C here, which is the angle outside. Now, if the sum of those angles inside here is 180, this guy here plus this one should also be 180 since it's being cut from a straight line. So just to give some names here, if I call this D, D plus C should be 180 because it's a straight line cut, but also A plus B plus D should be 180 because this is the sum of the internal angles of a triangle. So if D plus C is 180 and A plus B plus D is 180, then A plus B has to be equal to C. So this basically means that this angle will be A plus B. So the exterior angle of a triangle is the sum of the internal opposite angles. Now, the other rule is simply when you have a quadrilateral, the sum of the internal angles is 360. So in this case here, A, B, C, D, A plus B plus C plus D would be 360. Now, just like this one, A, B, C, D. Notice that the shape doesn't matter as long as it's a quadrilateral. Quadrilateral. Oh my god. Okay. This one is also a quadrilateral. It's a special quadrilateral. That's a square. So we could even put some small squares here just to mean that all of them are 90. And this one is actually very simple for us to visualize, because if this is 90, if this is 90, this is 90, and this is 90, how much is 90 times 4? 360. What about this rectangle here? Well, it's a rectangle, so all angles here are also 90. So again, the sum of those internal angles should be 360. Now, let's say that I do not accept that easy, that the sum of the internal triangles is 180. The sum of the angles on internal to a triangle is 180. So what I'll do here, let's do a thought experiment. So this is the triangle that I'm trying to to show you the angle. So A, B, tablet, and C here. Okay, so what we're gonna do here, let's complete that rectangle. So if I was to just get a similar triangle here to fit, what we would have is roughly this. Alright, so that's a rectangle. Now, if this angle here is B, this will also have to be B. This angle here is A, so we'll have another angle here, and we'll have another angle here. Now let's take a look. Isn't this side parallel to this one? Right, and this one is parallel to that one. Right, so we do have, in fact, now two pairs of parallel lines. Now, the angle that this line here is making with those parallel lines here is C. So, as we have seen before, take a look, this will also be C. This would be C as well, C. So they are in the same spot, or you could work for this as C as well. All of those are C's. What about A? Well, this here is A, so this angle here is also A. If we extend this line here and this one, then here we would also have A, because they are, take a look, two lines crossing at this point. This one, the angle with this one is A, so it's the same angle here. And now this should be the same as this angle here. So take a look at the shape that we have inside now. I'm going to clean the image a bit. There you go. Now, if we sum the internal angles of this rectangle, what do we get? Well, B plus A plus C here plus B again plus A plus C. So we have made a full turn, taking into account every angle. And well, the rectangle is fairly simple to see that the sum, since all angles here are, well, if it's a real rectangle, it's not just a shape like that, but all of those angles should be 90, so the sum is 360. We know that. But can we combine any of those angles here? Well, I've got two A's, I've got two B's, and I've got two C's. So couldn't I write this as 2A plus B plus C? I've got two of each, which is 360. Now, if I was to make this the simplest, I could divide both sides by 2. And if I do that, I will then get A plus B plus C is equal to 180. And that we go. There we go. So in our original triangle again, our angles were A, B, C, and now we know that the sum of them is 180. So those properties that I've just discussed with you right now are the ones which will be the foundation for everything which is going to come after when we're studying geometry. So it's very important for you to have those concepts very well understood, and let me know if you have any doubts. I'll be glad to help. Thank you very much and have a nice day.